Okay. So before I finish up the slide set quickly, and then go back through to talk about what where I would focus on the final exam, are there any questions on anything that you want me to cover in preparation for the final exam? Any concepts you want me to review or anything like that? Going once, going twice. Okay, so then let me quickly kind of just wrap up the loose ends for the end of the slide set here. We don't have that many slides left to kind of go through. Last class, we talked about interfaces at the high level. We specifically looked at the runnable interface, which is built into Java that effectively dictates that you must implement. So implementing classes of the runnable interface must implement a method called run. And that's it. That's all the interface says is you have to write a method called run and put crap in it. Actually, you don't even need to put crap in it. You just have to write it. You just have to implement a method. And if you want to put nothing in there, you can. In fact, that's how threads, the default thread class works. So the default thread class, notice this slide here, the difference between interfaces and classes. The default thread class implements a run method because it chooses to implement runnable, but that run method does nothing internally. So if you want to have a thread do something special, you have to override that method one way or another. Either the way we did it is we created our own class called myThread that extends thread, and then we implemented our own version of the run method. And that run method automatically would get called by the thread start method. That's the special magic sauce for threads. But an interface is different. An interface is kind of like a class, but it just dictates what you have to do. So with the thread class, we kind of saw both. We saw the runnable interface, which says you have to have a run method. Then we saw the class thread, which implements the runnable interface, implying that it has a run method. And then we used inheritance to extend the thread class with our own class and chose to override the run method with our own version of it so that when we told our version of thread to start, it called our version of that run method. Okay, that was the stuff we looked at last class. All right, now if we were to go and implement our own interface, which I'm just going to show you code examples of this because it's nothing crazy. So for example, here's an example of an interface called animal. Okay, I think I kind of mentioned that typical naming convention indicates that interfaces typically have an able at the end of it, A-B-L-E. So like runnable, serializable, that kind of stuff. So animal would be kind of a strange name for an interface, but this is still accurate. That's just a naming convention. All right. So with a class, we say class followed by the name. For an interface, you just say the word interface followed by the name. So this is an interface example. Notice it's inside of a normal plain Jane Java file. And we just say interface followed by the name of the interface. And then we've listed two methods. So anything that is an animal, anything that implements the animal interface must have a function public void eat, must also have a function public void travel. Notice that we do not implement these in here because an interface is not an implementation. Instead, an interface is a requirement that implementing classes must implement these. All right, so that's all an interface is. If you write your own interfaces, you're basically writing something that polices implementing classes to make sure they have at least that baseline ability that all implementing classes should have. All right, and then on the flip side, if you have your own class, so for instance, you have something called a mammal, and you say this guy implements animal, notice that we wrote eat and we wrote, actually, what was the other one we're supposed to do here? Eat and travel. So we wrote the eat method. We also wrote the travel method. But this class also then wrote some other methods, but these other methods were not required. The only methods that were required by us claiming we implement animal is eat and travel, because that's all that interface defined, declared that we had to do. So we can do more, but we have to at least do that. All right, questions on that? Okay, next thing, and we've mentioned this word before, but I'll mention it again here. This last part deals with inheritance, and notice we only have just a couple of slides in here. So this last part deals with inheritance. We have this concept called polymorphism. Polymorphism is when you have a method, more than one method with the same name, but a different number and or type of parameters. Not different named parameters, just a different number and or type. So you can't have a method called run that takes in an int A and another method called run that takes in an int B. Both of those methods are considered to be identical to Java. They don't care that you named your variable A in one of them and B in the other one. Okay, the fact that they both took a single parameter and that parameter was an int means they're the same, and that would be illegal. Okay, but polymorphism says that you have more than one method with the same name with a different number and or type of parameters. So you could have a method called run that took in an int A, and you could have another method called run that took in an int A and an int B. So now you have two methods, both named run, and they take in a different number of parameters in that case. Okay, you could also have a third method called run that took in a string S. So this one takes in the same number of parameters as the one that took in the int A, but in that particular case, the type of value it was taking in was a string. All right, so Java is then able to differentiate between those three methods with the identical name and figure out which one you're calling by the kinds of parameters you're passing it when you're using that method. All right, so that's this concept called polymorphism, and that's loosely related to inheritance. It doesn't have to be directly related to inheritance, because you can have examples of polymorphism in your own classes, and we've even done that a couple of times when we were writing like a URL class that had two different constructors. One constructor that took in the string of something, another one that took in like the JSON or something like that, or just had the thing hard-coded. So multiple constructors that have the same name as the class, but a different number and or type of parameters is also an example of polymorphism, even though they're constructors and not just methods. All right, questions about polymorphism? All right. Next, we have this idea of an abstract class, and this is directly related to inheritance. And when we first looked at inheritance back in 200, we would have talked about this at the high level. In Java, we have a special keyword for this. Sometimes because of inheritance, because of the way inheritance works, if you remember back to 200, we wrote our dungeon crawler, we had like an inhabitant class. And then we had a monster class and a player class, and both of those were inhabitants. All right, so the idea is that we would never actually create a generic inhabitant in our dungeon, but we still had a class called inhabitant because we used it as the base class for our two other classes, monster and player. Okay, because both of those guys were inhabitants. Now, technically though, the way we wrote it last semester, we could have created an instance of inhabitant. We just shouldn't have created an instance of inhabitant, because in real life we would say, well, it doesn't make sense for there to be a generic inhabitant walking around. We would only see players and monsters walking around, which are inhabitants but are kind of specialized versions of inhabitants. Java, as well as other modern object-oriented languages, have a mechanism for policing that, effectively saying you cannot create an instance of, in that example, the inhabitant class. If you were to write the inhabitant class in Java and label that class as abstract, what you've now done is you've said you cannot, the programmer cannot create an instance of this class. Instead, this class exists solely for the purpose of being a base class for other classes that you might then be able to create instances of. So in this example here, they have a class called animal that they've made abstract. And down here they say, hey, well, let's go ahead and create an instance of animal. Animal, my object equals new animal. This is going to give us an error. You've labeled this class as abstract, which means that this is not allowed. Okay, so that's all the abstract keyword does. The abstract keyword lets you, the programmer, have your code be self-policing. So if you are writing a class that you never intend to create a direct instance of, you can label it as abstract so that you either A, personally don't accidentally create an instance of it, or future people who are using whatever library you're writing don't accidentally create an instance of it. Instead, they use the classes that you wrote that use this guy as the base class as their mechanisms for creating instances of animals. All right, we can see that as an example here, where we have our abstract class animal. Now notice also inside here, we have an abstract method called animal sound. And then we have regular methods as well. So an abstract class cannot be instantiated, and an abstract method is kind of like an interface. So this is a situation where we want some of the features of interfaces, in that we want to force things that implement this, things that come from this. In this case, we're using the inheritance model. We want to force them to write certain methods, but at the same time, we also maybe want to give them some implementation. So notice here in this class animal, we've labeled one of our methods, animal sound, as abstract, effectively saying whoever inherits from this class animal has to write a method called animal sound that's public and void. They have to implement that guy. All right, but it's also given us another method called sleep that they've actually implemented. Remember, interfaces do not allow for us to implement methods. Interfaces only allow for us to describe the methods that must be implemented. An abstract class dictates that we cannot create direct instances of that class, whereas an abstract method says inheriting classes must create their own instance of this, this method. Okay, so in this case, we have an abstract class called animal, which exists for the sole purpose of inheritance. And then down here, notice we have class pig, which extends animal. So a pig is an animal, but then he's also a little bit more. But now notice inside of pig, we now also wrote our own method here called animal sound, which was defined inside of animal, but it was defined as an abstract method, which now forces us to have to write our own version of that method, since there was no implementation of it. So this kind of gives us you can almost think of it as like a super interface, an interface that has some implementation to it, but also has required us to have our own implementation of portions of this. But now we get the additional power of the inheritance model with classes. So a pig is an animal, and this is the animal sound a pig makes. Pig says wee wee. Then in the main class, we're allowed to create an instance of pig. So I'm saying pig, my pig equals new pig. I am allowed to create an instance of pig. Notice pig is not an abstract class, even though it was built in terms of an abstract class animal. So I'm allowed to build a pig, but I'm not allowed to build an animal directly. Instead, I'm indirectly building an animal by building a pig, which is an animal. Okay, so this abstract keyword exists solely to support the inheritance model and also allows you to make methods abstract, which kind of gives you some of the features of interfaces. All right, questions about that? All right, we've already covered that stuff. All right, kind of one last example here. We've been talking about interfaces a little bit. Now, a class in Java cannot extend more than one class. So the inheritance model in Java only allows us to inherit from one parent class. Now, you can inherit from a parent class and have that parent class inherit from another class, but you can't have a single class inherit from two different parents in Java. But you can say that a class implements multiple interfaces. So in this example here, we have two different interfaces, one called first interface, which says you must write a method called myMethod. Then you have another interface called second interface that says you must have a method called myOtherMethod. Now this class demo class claims to implement both of these guys. Notice it's just comma delimited here. So by saying it's going to implement first interface, he's saying I will follow the rules and implement a method called myMethod. Similarly, he's also claimed he's going to implement the second interface, which says you have to implement a myOtherMethod. So by this guy saying I'm implementing both of these interfaces, he is agreeing to implement both myMethod and myOtherMethod, which he does. So inside of this class demo that implements both of these interfaces, he's written myMethod and he's written myOtherMethod. So now down here, we can create an instance of demo class and we can call both of those methods. And this guy won't get screamed at because he's advertised he will adhere, he will implement these two interfaces, and then he followed through by writing the methods associated with those two interfaces. All right, so this won't give us an error. If we had come in here and we had not implemented myOtherMethod, for example, we only wrote myMethod, then we would have gotten an error here saying, look, you fulfilled the requirements of first interface, but you claimed you were also implementing second interface and you didn't fulfill the requirements of second interface. All right, we kind of get the purpose of these interfaces. They're like a self-policing type of mechanism that allows you to describe a standard that you want implementing classes to follow, where the abstract keyword allows you to create a base class as well as giving some requirements for methods that must be implemented. All right, questions about any of that? All right, so that wraps up the topics for the 250 class. The next class in the sequence for the programming sequence is the CSC250 class, which is offered in the fall. In that class, we write our code in C++, so we switch to a different language. Again, a popular language. We have a little bit more work directly working with pointers, things like that. If you are a software engineering or an AI and robotics concentration student, you are required to take CSC250. If you are either a cybersecurity, computer animation, or information systems major, you can take it as an elective. I would strongly encourage everybody to take the third programming class. Frankly, it should probably be required in all concentrations, but we only have so many classes to go around. But remember, in our the way our major works is you do have a requirement of one CS elective from the tech core, so that can be CSC 300, but you also have 21 free electives to take with any classes you want. We don't require a minor, so I would, even if you've already taken another elective, I would still encourage you to take the third semester programming class as with one of your 21 free electives. The more programming you can get, the better. I realize some of you hate it, some of you might like it. Hopefully most of you are somewhat frustrated by it because it's not easy, but hopefully you're at least seeing that you're better at it now than you were at the end of 200. And by the time you get to the end of 300, you should be even better at it. All right. Again, it's like a sport. You got to just keep putting in the reps, and that's just the nature of the beast. And we keep switching languages on you, so you see the similarities between these things. And you can also then claim in your resume that you've been exposed to these different languages. And when you go and get a job, you're not immediately deer in the headlights type material. All right, so strongly encourage you to take the 300 class in the fall. You can certainly, if there's a time conflict, you can certainly watch the videos and that kind of jazz. But I would not take time off of programming classes and then come back unless you were going to be diligent and practice in the meantime. It's already going to be bad enough when you don't practice over the summer and come back and kind of are rusty. All right, so questions about the next course in the sequence, that CSC 300 course. Okay, so then what I'm going to do is I'm going to flip through the slides here, and I'm going to give you highlights of what I feel would be things that might make an appearance on the final exam. Final exam will be 10 questions. It'll be on Blackboard. I will have it up by midnight on Sunday. You just have to complete it by midnight on Friday of next week. Okay, so there's not a set time. But you will need to complete it all in a single sitting. I will probably set the time limit for the exam at 3 hours, but I designed the exam to take an hour. So if we were doing this in class, a normal final exam schedule is a 2 hour long thing. So I'll design it to take 1 hour. I'll give you 3 hours in case there's a weird online glitch or something like that, but you do need to complete it all in one sitting. So whenever you start it, be prepared to finish it, and make sure you do it before midnight on next Friday so that I have time to grade it over the weekend, because I have to have final grades in by the following Tuesday. All right, so again, that will be up and available by midnight on Sunday. It'll probably be up before then, but I'll promise you it'll be up by midnight on Sunday. So let me scroll back here. Now, I will say that a majority of the exam will be stuff since the midterm. And remember, the policy is if you do better on the final exam than you did on the midterm, I will replace your exam grade on the midterm with whatever you earn on the final exam. At the end of the day, I just have to give you a grade that represents how well you've mastered the material. And if you weren't quite up to where you needed to be on the midterm, but you've made progress since then, you can fix a bad midterm performance. All right, so some of these early things, I mean, these are important concepts. They should already be ingrained in you, but I'm probably not going to ask a specific question about this slide or this slide. I'm just going to start flipping through until I start finding things I might ask questions about. You certainly should be able to write an error-free hello world program in Java. I don't know that I would use a question on this exam for that, but there's a chance. I'm an advocate of I'm an advocate of two things that maybe seem to be in conflict, but they're not really in conflict. I don't believe programmers should memorize large chunks of a language. the skill you should have is being able to read documentation and put it into use. All right. But I do think it's worthwhile memorizing the kind of the starter template for common languages you might work with. So you should be able to quickly get a starting point for a Java program like we have here on the right, so that you can quickly get a program started and get it running, making sure your environment is functioning, and then start adding stuff to your implementation from there. All right. Again, not sure I'll ask you specifically about Hello World, but you should be prepared to do it. That should be something that's ingrained into your soul. I would say it would be fair game to ask you something about Git or GitHub. I don't envision that I would, but you should know what that tool does and how we used it and that kind of stuff. So, you know, it could come up in some form, but nothing dealing with deep knowledge of it. You should just be familiar with its use. All right, so this is our area where we're talking about the different kinds of programming languages. We certainly should be aware of these. I don't know that I would ask you a specific question of it about it on the final, but it would be fair game. You know, the compile versus interpreted argument, where Python was interpreted, Java is compiled. What's the difference between those? Similarly, loosely typed versus strongly typed. Fair game, but probably low chance of showing up on the exam. I think I'll have enough other questions to ask. I will say that this exam will probably be more programming than the midterm, and those programming questions will probably come in a couple of formats. One will be, I will show you some code and ask you what this code does, which you've seen before. And again, I'm not asking you to tell me what each line does. I'm asking you to walk through the code with some examples, and then ultimately tell me, what problem does this solve? You know, like if it's a function that takes in a string and ultimately it builds up a new string that is the original string in reverse, I want you to tell me this function reverses a string. Don't tell me that line 1 does this and line 2 does this and line 3 does this, ultimately not telling me what it actually accomplishes. I want you to show that you know how to read code and understand, express what it's actually doing as a whole. What problem is the code as a whole solving? So that'll be one type of programming question. Another type of programming question would come in the form of me saying, write a method that takes something as a parameter or some things as a parameter and does something. Another programming type question would be, write a class that keeps track of these pieces of information and write like an appropriate constructor as well as getters and setters. You know, you should be able to create an object off the top of your head, similar to what we did with like Hearthstone cards and that kind of stuff. And then there would be another type of programming question where I give you some information. Maybe I say that there's a class X that exists that has the following 3 methods, and I give you the method headers for those. And based on whether they're static methods or non-static methods, you should know how to use them. And I might ask you to write a method that does something that requires you to utilize instances of those classes or those classes directly. So again, showing me that you understand how to read documentation and use tools by a description of what they do, as opposed to having to always implement everything yourself. In terms of the method type questions I like to ask things that, kind of things that are appropriate for exams where I'm trying to kind of measure your programming competence with a lot of little drill type things, as opposed to longer, more complex things that might be appropriate for a homework assignment where you have plenty of time to work through it, I tend to ask questions. The programming questions would be, like maybe string manipulation, reverse a string, remove the vowels from a string, add an extra, space or something like that, or duplicate every character in a string. Similar type things with arrays, that kind of thing. So make sure you can write logic that leverages creating some variables, writing some loops, maybe having a method, writing two methods and having one method call the other one as a helper, that kind of thing. I won't ask you anything about bitwise stuff. That's stuff that hopefully you're doing in the 325 class. I know several of you are taking that. Or bit shifts. Definitely be familiar with arrays. Be able to explain to me the concept of contiguous memory in a row, why arrays need to use those things. I don't know that I'd ask it, but that's an important concept. But certainly be able to write code using arrays. There will be at least one conversion question in there where I give you a number in some base and ask you to convert it to some other base. That's something that you should be able to do. Every Lippmann exam you ever have will have at least one conversion question. All computer scientists should have that as a something they can just do in their sleep. Let's see. Like I said, in the 300 class, we'll be working a lot closer with memory where we have a special syntax for pointers, things like that. So things like this down here are going to be commonplace for us in the 300 class. This isn't something that that you're responsible for on this exam, though. Obviously, be able to do your loops, be able to increment. These are all things that certainly fair game. I'm not going to ask you generic questions about them, but you certainly need to be able to use all those things. Be very comfortable with strings, be very comfortable with arrays. So collections of things tend to be a major part of the questions I tend to ask on exams, working with strings, working with arrays. This concept here where a class is a collection of fields, constructors, and methods. So if I gave you a description, for instance, here, I said this is what a simplified Hearthstone card was. We have a cost, we have an attack, we have a defense, and we have a name. Well, you should be able to create a class keeping track of these four fields, writing a constructor for this guy that seems appropriate based on those four pieces of information. If you remember, we did an example with polymorphism where we actually had two separate constructors for a Hearthstone card. One took in four parameters, one for cost, one for attack, one for defense, one for name. The other one took in a JSON string and created a card from a JSON string extracting the cost, the attack, the defense, and the name. So that's an example of polymorphism where we had two different ways of building a Hearthstone card. We could pass it four individual, well, three integers in one string, or we can pass it a single string that was in JSON that we can then internally parse and get our four values out of. Certainly understand the concept of public, private, protected. Public and private being the most important. Protected only really comes into play with inheritance. Definitely understand, like if I ask you to write a class and then appropriate getters and setters, that class should have its fields be private. And then the getters and setters should be the way you access or change those private fields. Certainly reading stuff in from the user might be fair game, but I probably wouldn't ask you to do anything in any of our methods. And I'll take that even a step further because this is a common mistake people make. When I ask you to write a method that takes something in as a parameter and does something with it, I'm asking you to write something generically. Don't have the first line of your method and prompt the user for something and use the scanner class to read it in. Methods are reusable chunks of code that take 0 or more parameters and do something. So if I say it takes in a parameter, that means it's going to have a list of things it's going to take in as a parameter, and whoever calls this method will pass it the data that it needs to operate on. Now, that isn't to say maybe that person didn't get their information using the scanner class to read it in, but a method should not be written in terms of requesting information. Well, the methods I'm asking you for wouldn't be written in terms of requesting information from the user. Instead, that information came from somewhere, and those methods are meant to be called passing it the inputs required for that method. So I would think it would be very unlikely that you're going to have to use the scanner class on the exam. So if you find yourself using the scanner class, I would think very carefully about it, because that does show a level of incompetence related to how methods work. And at this point, we've been working with methods for 2 semesters. Definitely be comfortable with concatenation. I think it's almost guaranteed that you'll have some sort of method dealing with, concatenating strings together, starting with the empty string, concatenating things onto it. Super common type of drill programming question. JSON would be fair game in terms of me showing you some JSON or asking you to write the JSON for representing something. I wouldn't ask you to use the JSON library that we had done in class to pull stuff out of JSON on an exam. That's something that you would just look at a code example for and get it working, and with not a time constraint on you. So you certainly should know what JSON looks like, but you would only need to deal with it at be able to look at it and tell me what it contains, or be able to maybe convert an object into a JSON string by hand, like not writing code to do that, but you actually saying, okay, well, here's a player that has a first name that's Mike and a last name that's Lippman. Here's the JSON equivalent of that. The instance of operator, important it could show up on the exam. I would say it would be relatively low priority that it would be on the exam, but this allows us to ask whether a specific class is an instance of another class. So it's a Boolean operator to say, is this one of these guys? It's not that it wouldn't be fair game on the exam, but it might be hard for me to ask kind of an exam appropriate programming question that would ask you to use that. So I think it's unlikely it would show up on there, but it is an important thing to know. So I'll say it's fair game. Certainly typecasting, if you have a double and you typecast it to an int, it truncates. So understand that kind of stuff. Also make sure you remember that since Java is a string-based language, getting things into string format is very convenient. If you have the int7 and you want to turn that into a string, you just use the empty string and concatenate onto it that 7. Okay, but typecasting allows you to put something in front of a variable, a type, and have it turn into that. Keeping in mind that some things it won't work for. So for instance, you can't have an int a is equal to 7 and then just typecast a to be a string. Instead, you would need to build a string out of a. Similarly, if you had the string 7 and you wanted to turn that into the int 7, you can't just typecast that string into an int. You instead have to call a method like integer.parseInt to extract the integer out of that string. Okay, so typecasting isn't an always works for everything thing. It would have to make sense. A double like 3.14 turning into an int Makes sense. We no longer know how to hold the decimal point value. So a 3.14 becomes a 3. A 3.99 also becomes a 3. When you truncate, when you typecast something to an int, no rounding is occurring. You're just truncating the decimal point. Be able to work with arrays. Probably would not ask you to do anything with a for each loop, but there'll be for loop stuff on there. I don't know that I'd ask you a question that says you must use a while loop for this, but there will be plenty of questions that will require loops. You can use a while loop, you could use a for loop, you could use a do while loop if it made sense. But I wouldn't pigeonhole you into a specific type of loop, but they all basically operate the same way. Definitely understand the modulus operator, where you can get the remainder of an integer division versus just the integer division. String comparison is an important thing. Sometimes this is a hard kind of question to ask on an exam, but I'll still make sure, I'll still say it's fair game. Understand that the double equal sign here, that's the equivalence operator. So we're asking, is this value the same value as this value? It's comparing memory addresses, as opposed to the contents of A being the same as the contents of B. All right, so that's why A equals B is the same is true, because A and B are both equal to the string literal hello, where this guy is, both of these guys are stored at the same memory location in the computer, because they're only going to store the string literal hello once. But A is not equal to C since we asked for new memory here. So even though we built this new memory using the same string, this hello lives in a different location in memory because we use the real estate agent new. So A equal to C is false. Because this is one memory address, this is a different memory address. And using the double equal sign here, we're looking at the memory addresses, not the contents of the string. If you want the contents of the string between two strings, you use the strings equals method. You ask, is A equal to C? And what you're saying is, does it contain the same sequence of chars? So that's something you should definitely understand. Be able to write functions. Make sure you understand how return types work. Parameters. Be able to, if I asked you to write a function or write a method that does something, be able to know what I'm even asking you to do. Don't just give me 4 lines of code with no structure around it. That's not going to be worth a whole lot of points at the end of a second semester programming class. You should know what a method is and be able to write it. Understanding that functions and methods are kind of synonyms. It means the same thing. Be able to write classes, know the public, private, protected stuff. Definitely know static versus non-static. This is going to be on the exam in one form or another. Such an important concept in terms of reading documentation and stuff. This is something that just should be ingrained. That understanding of the difference between when you're defining it versus when you're using it. If you're defining a class method, you use the static keyword. If you're defining an instance method, you do not use the static keyword. If you are using a method that was defined using the static keyword, you call that method using the name of the class in which the method was defined, because static says it's a class method. If you are using a method that was defined without the keyword static, you will first need to create an instance of that class and then use that instance to call that method. All right. Super, super, super important. Again, it's like a top 5 most important programming type things. And it will be on the exam at least once, and it won't be good if you don't have those things straight. There's no excuse for not knowing those things. Basically commit this slide into your soul. What you're looking at right here, the difference between defining it and calling it, this slide says it all. If you can memorize this and be able to refer to it in your memory whenever you need it, whenever you're asked to read documentation. It will pay off so many times in your career. Won't ask you anything about file IO. Array lists would be fair game, but that would fall into that same category as like strings, arrays, array lists. I might ask you something about the difference between an array and an array list in terms of array list can hold an arbitrary number of things, where an array, you have to give it a fixed number of things you're going to hold initially. But we asked that on the midterm. I think it was pretty well, I think most people got it right, so I probably would not waste a question on asking that again. But certainly if I gave you some code using an array list, that shouldn't be like some foreign language to you. You should know what that is. And if you wrote one of your answers using an array list instead of an array, that would be okay, unless I specifically asked for an array. None of the algorithm performance stuff, big O notation. It's interesting that, you know, we can think about the comparison between algorithms this way, but it's not important for what I'm trying to test on this exam. I'm testing computer programming competence. How have you evolved as a computer programmer since CSC200? Same thing with our searching algorithms, linear search, just going from the beginning to the end. I won't ask you specifics about some of these different sorting algorithms like insertion sort, stuff like that. Probably wouldn't have you write something like that on the exam either, just from a time constraint perspective. I would give you less complex, but still complex enough problem solving little puzzle type programs, methods to write on the exam, showing that you understand programming. Because one thing I definitely don't want you to do is I don't want you to you know, have memorized some chunk of code that you have no idea what it does, and that just becomes your answer to some question that you know how to answer. That just screams incompetence to me. It's not going to earn points. All right, so I should not be asking you a question about reversing a string or something like that, and have you throw in the insertion sort code that, you know, you probably shouldn't be pulling stuff out of your notes anyways during the exam. It's close book, close neighbor, close internet. I want to see what your brain's capable of. But at the end of the day, you know, if you just paste in some code from a completely unrelated problem, that's not worth points. On the exam, there might be a couple. I'll probably ask something with the design patterns. So you'll be responsible for understanding what a generic design pattern is, what MVC means, what a singleton is, and when we use it. Those are the singleton things, something we've done more recently with the singleton versus the extras. I probably won't ask you very much specific to Android. Android was just a way that we used to explore our Java a little bit, applying our Java knowledge to a different way of building a user interface and stuff like that. So you probably would not have to, you know, write code that launches a new activity or something like that. It would be fair game for me to give you some code and tell me what this code does, something like that. If I were to create an intent, add a couple of strings or integers to the extras of it, and then launch that intent, you should be able to explain to me what that code is doing. But I won't ask you to write a lot of Android specific stuff on the exam. That falls into that category of you know, we just don't have time for it. Let's just quickly finish zipping through here. So same thing, scroll view, list view. That's Android specific, won't ask about that. That was the stuff. Recursion, you should understand it. You should be able to do something simple like a factorial type problem, but you know, generally I'm not going to ask tons of recursion type problems. That would be something more on the 300 class, and then 470. Same thing, merge sort probably won't be on the exam. And now we're pretty much here where we were recently. Threads could be on the exam, but it wouldn't be a major implementation type thing. It would be more of, you know, asking questions, what are threads for? It would be fair game for me to give you some code and asking you what it does that creates some threads, but we didn't have enough practice with it for me to expect you to use it in one of the programming problems. Okay, so questions, comments, concerns, bribes. All right, well, I will see everybody, well, next semester, hopefully. Take the 300 class. I would strongly encourage you to do that if it's not already in your schedule. Otherwise, like I said, the exam will be up by midnight on Sunday. I just need you to turn it in by midnight on Friday. But it does have to be done in one session, and it is closed book, closed note, closed neighbor. I want this to be your own work. All right, I will talk to you when I talk to you.